Assalamualaikum and a very good morning. I'm and my group members, that is AMIR, ISHAK, MOHAMMAD AFIQ and Mohammed HAMYZAN, will present about the thermal ice storage, that is calling TIS. So for the introduction, that is thermal energy storage, TIS, is likely a battery for a building air conditioning system. Ice is made and stored inside the energy storage tanks. Full storage charge is reached when the ice is typically 1.1 to 1.5 inch thick. Thermal ice storage is a proven technology that reduces chiller size and shift compressor energy. The chiller operation during non-peak hour cooling a glycol solution to sub-freezing temperature. Ice is ultimately melted and used as a cooling agent. So this is how the thermal ice storage works. As we can see, during night time, water that contains 25% ethylene or propylene glycol is cooled by chiller. So the next, second step, ice is created uniformly inside the ice bank tank, counterflow heat exchanger tubes. So for the third step is ice storage tanks deliver the stored energy to a building to augment the offset electric chiller cooling. So the last one of the step, a fan blows air over the coils to deliver cooling to the occupant space. So this is a thermal storage system schematic. So as we can see, the thermal storage coil will supply to the heat exchanger, that is a cool water. So the heat exchanger will supply to the chiller water pump going to building air handler. So the supply air will become cooler, and then the water that has been supplied will be returned to the heat exchanger, and the heat exchanger will supply to ice water pump going to the thermal ice storage. So that's all from me. Thank you. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Abdul Rahman, and I will continue to the advantage of thermal ice storage. So thermal ice storage can be the most cost-effective and reliable system for cooling and provides a steady source of low temperature for cooling application. Buildings such as malls, hospitals, and office can have a longer lasting cooling effect without having to spend much effort. This system is also environmentally friendly because it helps to lower energy consumption and reduce greenhouse emission. So the first advantages of thermal ice storage that we're gonna look about is firstly is reduce environmental impact. Thermal ice storage system can take advantage of having cleaner, less expensive, and more efficient energy. It is because it stores energy as ice during nighttime. It also helps reduce energy losses by 4 to 5% compared to storing ice during the day. Next, thermal ice storage can support clean renewable energy. The unpredictable resource from nature may arise the need for energy storage. Thermal ice storage can provide an economic strategy for utilizing renewable energy for cooling system. Next, thermal ice storage also can reduce energy costs. Electricity usage during nighttime is much cheaper compared to during daytime. Moreover, ice thermal storage can also lower peak electrical demand for the system by 50% or more. The fourth advantage of thermal ice storage is it can save energy. When the system is designed to take advantage of the low supply water temperature from an ice storage system, energy use is significantly reduced. Low temperature chilled water utilizes low horsepower pump but still can provide low temperature air with lower horsepower fans. The efficiency of the chiller can be increased due to lower condenser temperature at night. The next advantage is it is low first cost because thermal ice storage can use smaller chiller and heat rejection equipment. It also has reduced piping and pump size. The ducting and fan size is also reduced, and generator size is also reduced. So it can contribute to a lower first cost. And the last one is reduced maintenance. By using smaller capacity equipment, it reduces the needs of maintenance. The thermal ice storage itself does not include too much of moving parts, therefore does not require additional maintenance. Okay, now we're gonna take a closer look on the thermal ice storage and its accessories. Thermal storage systems have been in existence for many years. Although many early applications involve systems installed in dairies, churches, and theaters, most current applications are used for continuous comfort cooling. The purpose of a thermal storage system is to create thermal energy and store it for use for another time. There are several types of thermal storage system in use today. This system can be either full or partial storage type. In the typical full thermal storage system, the refrigeration system chillers generates ice at night when electrical utility rates are typically lowest off peak, and during the day when utility rates are higher on peak, the ice is then melted to provide cooling to the building. Okay, next is the thermal ice storage part and accessory. The first accessory of the thermal ice storage is air agitation pump. The pump has rotary compressor that pumps air through PVC pipe attached to the underside of the coil. The bubbling action through the coil is to ensure the even water temperature throughout the container. The next accessory is ice thickness sensor. The probes in the sensor is used to measure the thickness of the ice on the coil. The sensor distinguishes the resistance between ice and water. When ice is fully built, the sensor signals the automatic temperature control to terminate ice build mode. This means when ice is fully built in the ice storage tank, there will be signals sent to automatic temperature control to stop the process of ice building. The third accessory is the automatic glycol zone valves. As each thickness sensor reaches the full charge level, glycol zone valves end the ice build mode for the coils. Ice build mode is terminated when all glycol zone valves are closed. The next part is ice inventory sensor for external mat system. Load cell is used to measure the ice buoyancy. The load cell measures small strain changes between the coils resulting from the ice build-up buoyancy effect. The strain factor is then converted to a signal that is used by automatic temperature control to display the amount of ice left in the container. And the last accessory is the ice inventory sensor for internal mat system. As ice is forming or melted, the water level will change. The ice inventory sensor will measure the water rise. Then this is then converted to signals that can be used by automatic temperature control as part of the operating strategy. Automatic temperature control will not begin ice build mode when the full build level is reached. Automatic temperature control can also use the signal for safety alarm when the water level is below the no ice setting.
Assalamualaikum and very good morning. My name is Muhammad HAMYZAN bin ADNAN, and I am going to explain about the installation procedure for thermal ice storage. So for the first part is piping. Coil connections are grooved to suit the mechanical coupling, and a relief valve must be installed and set at 150 psi between shut-off valve and coil connection in order to protect from excessive pressure. So beside relief valve, shut-off valve also must be installed, and its function is to isolate the thermal ice storage from the system. So for the next part is tank filling. So firstly, we must remove the excess cover on the top of the unit and then fill in the water until it reaches 0% ice build level, and this is recommended by the manufacturer. So for the third part is system charging. A 25% solution of propylene glycol is used for thermal storage systems, and the solution should be mixed and tested before applying it into the system. So before implementing the solution into the system, we must check the concentration of the glycol using refractometer. So this is the another two requirements for installation. So for site requirements, the thermal ice unit should be placed with sufficient clearance to allow access for inspection and maintenance work, and the minimum clearance of 18 inches side to side and 36 inches end to end is required. As for the support requirement, the unit must be supported by a level concrete pad, and the pitch of concrete pad must not exceed 1/8 inches per 10 feet. For the next part is operating instruction. So first, I'm going to explain about the startup procedure. Firstly, clean all the debris from the interior of the tank and then flush the ice tank with water. Next, inspect the air pump for any damage. And lastly, start the air pump and make sure the rotation is correct. So after 24 hours of operation, we must check the air pump for any unusual noise or vibration, because this noise or vibration might indicate damage in the component. And next step is check the water level and adjust if required. Then adjust the water distribution using balancing valve, and lastly readjust the valve if necessary. For the next part is operating instruction. So for seasonal shutdown procedure, the first step is we must pump out the coils and store the refrigerant in the high pressure receiver. Next, we must allow any ice present on the tubes of the coils to melt. And then we must leave the drain connection open to allow any water that might enter the tank to drain out. And lastly, we must properly position the insulated tank covers to minimize dirt. And for safety reminder, do not overflow the tank, do not close the inlet which is for the liquid supply, and then do not close outlet or the wet return valve on the coils without bypassing the relief around the valve, because this will prevent an excess build-up of pressure in the coils. So for the last part is safety precaution. So any adequate safeguards such as protective enclosures should be taken in order to prevent damage to the equipment, its associated system and the premises. And we must also doubt about safe and proper rigging, installation, operation or maintenance procedures. And lastly, contact the equipment manufacturers or his representative for advice regarding the device.
Assalamualaikum warahmatullahi wabarakatuh. My name is ISHAK bin Muhammad FUZILAH. I will continue to explain about the maintenance process and schedule. Among the cause of maintenance process is needed is when the technician found the damage of corrosion protection. Second one is sign of scale formation or corrosion. The third one is accumulation of dirt and debris. And the lastly is presence of biofilms. Maintenance and cleaning process. The first one is every component of thermal ice storage play an important role in providing cool air to the consumer. The second one is every component must be inspected and followed by proper corrective action in the event of failure. The third one is important to keep the thermal ice storage clean to maintain its efficiency. And lastly is to prevent uncontrolled bacteriological growth. There are several processes need to do at each component. The first one is ice chiller tank. It need to check the trash or debris in the tank. After that, need to clear the tank, drain the tank and flush with fresh water. For the ice chiller water level, it need to inspect water level in the ice tank and on monthly basis. After that, ice must be melt completely to check water level. And lastly, the water level should be maintained 25 mm above the height of the coil. For the coil, inspect the obstruction damage, corrosion and fouling. After that, remove any obstruction on coil. And lastly, any damage of corrosion need to be repaired. For the ice quality controller, it need to check the control sensor for any visual sign of damage monthly. And lastly, check the conductivity of tank water annually. This slide show the cooling medium that need to be maintained. The first one is air pump. Air pump should run at minimum during the first 3 hours of ice build to ensure the homogeneous water temperature in the tank. After that, for the glycol, check the glycol solution concentration every 6 months. Adjust the concentration using proper type of industrial inhibit glycol. For the refrigerant, clear any refrigerant coil from the coil every 6 months and using the purge connections. For the air distribution piping, inspect the PVC air distribution piping for cracks and see any sign of damage at initial and seasonal startup. This slide shows the maintenance schedule for ice storage units. The first one is type of action, inspection and monitoring. For example, general condition it need to check every startup and monthly. For the ice thickness, it need to check every startup and monthly. For the cleaning procedure, for example, mechanical cleaning, for air filter, it need to check or maintain every monthly or annually. For the disinfection, it need to check every startup or annually. This is the ice storage equipment checklist. The first one is cover, coil support, glycol connection, galvanized steel coil primary liner, extruded polystyrene insulation, secondary liner, wall panel, side tube, operating control, ice inventory sensor. All these things need to check every monthly or annually. That's all from me. Thank you.